the next one, as you can see, it's a little bit different, mostly because I give you the graph. Okay? Mostly because I give you the graph, okay? And what's going to happen is, from the graph, we have to be able to figure out what's going on. Okay? That is, we have to figure out what the function is. Okay? Okay. All right. Now, okay, so here's our graph. It looks like a parabola, so we know it's going to be quadratic. We know the vertex, as you can see, is this point 1, -4, right? Again, the vertex is where the graph changes direction. In other words, as you're walking along the graph, walking along a trail like, notice we stop and we change direction. We were walking down, and now we're walking up. We change direction at this point. So because of that, okay, because of that, this is the vertex. It's not the formal definition of the vertex, but I figured it's good enough for now. So we know the vertex, and just like in the other examples, we have to know another point on the graph, right? Just like in the other examples, if we know another point on the graph, we're good. We actually have 3 points here. We have -1, 0, 0, -3, and 3, 0. But you can use any of those points. I mean, you could use any one of those. Okay. Now, since we have the vertex, just like before, we know what hk is. That's equal to 1, -4. So h is 1, k is -4. Right? Again, we have the vertex, which is also hk. So we have hk is 1, -4. And just like before, that tells us h must be 1, k must be -4. So what do we do next? We substitute. H is 1, k is -4. So we get this so far. Just like before, we're not quite done yet, right? We have the a to handle. But that's where you can use any of the other points. So I chose 3, 0. That was kind of randomly. That was random, I mean. I could use any of the points. But when x is 3, the y value must be 0, which is the same as saying f of 3 must be 0. So when x is 3, y must be 0. Now we can figure out what a is. We have a is we have 0, excuse me, is a times 3 minus 1 squared minus 4, which is this. A times 4 minus 4. A times 2 squared, excuse me, minus 4, which is 4a minus 4. Again, I like to write the unknown after the number like this. It's just like what we do in polynomials. Just like in polynomials. So this is 0. Hence, this is true. Now we solve for a. So what do? We can add 4 to each side, divide by 4. We want to get a all alone. We get 1 equals a. That is, a equals 1. And since a is 1, you really don't have to write it. So we get this. So we get this. Again, if you were to graph this, you would actually get this polynomial, parabola. So, you could graph it in Desmos, I guess, as a check if you want. Okay. Are there any questions about this? Well, the next one I want everyone to try, we have this graph you can imagine. Now, I'm giving you this point here, which as we know is the vertex, right? Because again, if you imagine walking along the graph, you know, yada, 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 right? Once we get here, you have to walk the other direction. You change direction. That's where the vertex is. We have another point on the graph, but we actually have more than that. I mean, hopefully you can see that each box here is 1 unit, right? You know, this is -5 over here. Here we have -4. So here we have -3, here we have -2, -1, and 0. But basically we have at least 2 points on the graph. One of them is the vertex. So now we should be able to get an equation. We should be able to get an equation of this parabola. I want everyone to try that out now. I'm going to pause this and wait about a few minutes, okay? You know, maybe wait like, I don't know, 3 or 4 minutes. But I want everyone to try it though. Okay, I'll be right back.